Today we will learn how to navigate with precision, following a mission route established on the mission editor of DCS. The aircraft has already been cold started and is ready to taxi. The mission consists of taxi to runway, takeoff, fly low level following a pre-designated route, perform a visual navigation fix at B1, convert waypoint B3 into a target waypoint, perform a radar navigation fix at B4, mission ends at Nellis Air Force Base, no need to land. This training series is set on the Nevada map, and the approximate mission time is 15 minutes. By default, the pilot's body is shown. You can use left shift plus P to hide it if you prefer. When a voiceover tells you to interact with a cockpit element, wait until the voiceover has finished, before performing the interaction. If you are repeating the mission, note that most voiceovers can be skipped just by pressing the spacebar. Press spacebar to begin. The Viggen was designed primarily as an attack aircraft against predefined targets. Loitering over the battlefield, looking for targets of opportunity, is not its forte, as its weapon systems require the target to be entered onto the computer as a waypoint. So, for most Viggen missions you will need to have an appropriate flight plan onto the computer. You could enter a flight plan while sitting on the cockpit, by inputting waypoint coordinates, or you could use the DCS-10 map to design a flight plan on a point-and-click way. However, for this training, we will employ a pre-planned flight plan, created with the DCS mission editor. We will learn other ways to create flight plans for the Viggen on future training missions. For now, let's review the flight plan currently loaded on the CK-37 flight computer. Its details are on the kneeboard. Press right shift plus K to inspect it. This is a typical flight plan, where LS is the takeoff waypoint at Creech Air Force Base, then you will fly at low level through the waypoints B1 and B2, then a mock target is located at M3, and afterwards navigate back through B4 and B5, to end the mission at a landing base L1. As we have not yet trained on landings, we will just overfly Nellis to end the mission. No need to land for now. Close the kneeboard to continue. As the Viggen is one of the earliest military attempts at using a digital computer for navigation, its computer can only hold a maximum of 9 waypoints and target points, plus a starting airbase, and up to 2 landing airbases, primary and divert. For this pre-planned navigation, we will employ the following waypoint types: LS, starting airbase; B1, B2, up to B9, navigation waypoints; M1 through M9, target waypoints; L1, primary landing airbase; L2, secondary or divert landing airbase. Other waypoint types will be introduced during weapons and reconnaissance training missions. Normally, we would keep the computer in standby mode, BER, until we are less than 2 minutes from the takeoff, to prevent avionics overheating, but in order to be able to see how the waypoints look like on the navigation displays, we will turn the computer on for a bit. Turn the master mode knob to nav. Good, now turn the navigation data selector to its act position. On this mode, you can use the buttons on the navigation waypoint selector panel to manually select the next waypoint. LS skew, to select the starting airbase LS. B1 through B9, to select navigation or target waypoints. BX, to select mark points. We will learn about them on future missions. LMAL, to select the landing waypoint. You can press them now, to check the plausibility of the flight plan. For example, select waypoint B1. Good, the destination indicator displays B1 as the currently selected waypoint, and the nearby distance gauge displays the distance to it, from our current position. It should show almost 32 kilometers. The gauge units are kilometers up to 40, and tens of kilometers, mil, above that range. Press spacebar to continue. The course index, on the ring around the radar display, shows the course towards the selected waypoint, 124 degrees for B1. Note that the ADI and the nearby course gauge still show the heading the aircraft is currently pointing at. Press spacebar to continue. The fuel gauge displays, on its stripped needle, the minimum fuel remaining that would be required, at that waypoint, to complete the route as planned. For B1 it is about 31%, seems we could actually perform this mission without using any external fuel at all. The fuel consumption is calculated assuming that you will fly the Viggen at its economic airspeed, depending on the flown altitude, which at the low altitudes we will be using, is around Mach 0.6, except the leg towards our M3 target point, which we will fly at Mach 0.9. The figure shows the economic airspeed at various barometric altitudes. Press spacebar to continue. Feel free to check other waypoints of our flight plan, in the same way as you already did with B1, for example try B3. Note that on the destination indicator, it appears as M3 rather than B3, because this is a target point. Once you have finished reviewing the other waypoints, please reselect LS as the next waypoint. The destination indicator should display LS. Then, turn the master mode knob back to BER, standby, to allow the avionics to cool while we taxi. Contact air traffic control to request taxi clearance. The Viggens FR22 primary radio is already tuned to the ATC frequency. Press the key or button that you have binded to the FR22 push to talk. The DCS communications menu should appear. Select F1, request taxi to runway. Press spacebar once ATC gives you clearance.
Springfield 1-1, request startup. Springfield 1-1, cleared for startup, wind 146 at 6 meters per second.
Good, note that ATC assigned runway 13 to our flight. On the briefing we have an airbase diagram, with the taxi route drawn in orange. Press spacebar to continue. We are now ready to taxi. Release the parking brake, increase throttle, and let the aircraft roll out of the shelter. Taxi along the yellow line. Taxi towards the left, taking care to look right to make sure no other aircraft is coming that way. Turn right, to enter taxiway Charlie, making sure there is no other traffic on it. Good, this is taxiway Charlie. Proceed following the yellow center line. Turn right on the next curve, and slow down, as we are approaching runway 13. Stop the aircraft just short of the runway. You should contact ATC again, to request takeoff clearance. Press the PTT of the FR22 radio. The DCS communications menu should appear.
Springfield
Select
1-1,
F1, request takeoff. Press spacebar once ATC gives you clearance.
Springfield 1-1, you are cleared for takeoff when ready. Climb 300 at QFE 26.76.
Okay, now that you have clearance, look left and right to ensure there is no other traffic, release the brakes, and enter the runway. If ATC tells you unable to clear takeoff, ignore it as it is a long-standing DCS bug. Turn right, and align with the center line of the runway. Once aligned, press the wheel brakes and stop the aircraft to a complete halt. Good, we will now proceed with the rest of the before takeoff procedure. Main and backup heading indicators, main and backup altimeters, check. The headings of the ADI, central indicator, and backup course indicator, should all match and be around 145 degrees. The two altimeters should match each other, and be set to QFE. Press spacebar to continue. Master mode selector, set to nav. The HUD is now active, adjust its brightness with the highlighted knob. Press spacebar to continue. Enable the radar by setting its mode switch to its A1 or A2 position, its screen will illuminate. Adjust the highlighted knob to reduce the radar screen brightness and make it easier to use. Press spacebar to continue. Runway heading, check. Confirm our current runway heading by turning the computer data selector to its Bonnet-Grand's position, and the input-output switch set to UT. Do it now. As usual for Creech, the Viggens computer does not have the correct heading for runway 13, you will have to manually enter it. Set the INUT switch to in, to input the correct heading. The display changes to all zeros, to indicate that it's ready for the new data. Next, on the numeric pad enter 1450, corresponding to the 145.0 degrees true heading of this runway. To enter the new value, press LS. The display changes to all zeros once more, to denote that it has accepted the data. Now return the INUT switch back to UT, output. The new runway data that we just entered is shown, 1450. The Viggens navigation system now has the correct initial position and heading needed for the ADR navigation. Finally, return the computer data selector knob to ACT-POS, which will display the aircraft's current position, in longitude and latitude. On ACT-POS, the display shows the current longitude-latitude using the leading 4 digits, alternating both coordinates every 1 second. The 5th digit displays the status of the turn-nav system. If the status is 5, the turn-nav is making small corrections to the position keeping, increasing the navigation accuracy. However, turn-nav uses the radar altimeter and so it is able to work only at altitudes under 600 meters. The 6th digit shows the estimated error on the aircraft position, expressed in kilometers. Press spacebar to continue. SPAC, confirm it's on. Press spacebar to continue. Master warning and warning lights, check. Confirm that all warning lights are out, with the exception of the 3 green lights of the landing gear. Press spacebar to continue. HUD symbology, check that its information is correct, and it's on its lower position. Press spacebar, lights, set. Flip the highlighted switch to the takeoff and landing position, full forward. Takeoff pitch trim, check. Set an initial pitch trim of 5 degrees nose up, as we have an external fuel tank. Use 4 degrees when not using external fuel. Press spacebar to finish these pre-takeoff checks. OK, we will now proceed with the takeoff. 1. Apply full wheel brakes. 2. Advance throttle to maximum military power, check EGT. 3. Release brakes. 4. Use rudder pedals to steer. Advance throttle into afterburner.
Springfield 1-1, unable to clear for takeoff. Springfield 1-1, you are cleared for takeoff when ready. Climb 300 at QFE 26.76.
Monitor the timeline, rotate when it reaches its markers. Airborne. Retract landing gear. HUD is now out of takeoff mode. Turn left towards the waypoint dot on the horizon line, to head towards the B1 waypoint. Raise the HUD glass, do not exceed 500 meters altitude, to have maximum navigation precision. The jump of the HUD symbology was caused by the turn-nav system making a position fix. Steer the aircraft to head towards the dot on the horizon. Be sure to fly no higher than 500 meters AGL, to have the turn-nav system improve our navigation accuracy. To ease the pilot's workload, enable the alt-hold mode of the autopilot. Due to the inherent measurement errors in the aircraft's sensors, a level of position inaccuracy will exist, and increment during the flight. Therefore, the aircraft's calculated position will differ from the real position. Because of this position drift, it is necessary to occasionally update this calculated position, to eliminate this incremental error. This can be done by making what is known as a position fix. There are a number of position fixes that the Viggen does without pilot intervention. TILS fix, the instrument's landing system will make automatic position fixes, when the aircraft is on an ILS approach. Turn-nav, this system will create about 2 fixes per second, if the aircraft is within the radar altimeter range, is flying over land, and its current position has not drifted too far from the flight plan. Automatic initial fix, this fix is made during takeoff, when the aircraft reaches the runway's midpoint and establishes a starting point for the ADR navigation. Press spacebar to continue. There are two categories of manual fixes, either a navigation fix or a target fix. The procedures for both are almost the same. The difference is that a target fix corrects the position of just a single target waypoint, without affecting the remaining waypoints, while a navigation fix applies the same correction to every other waypoint of the flight plan. The computer can distinguish between both fix categories because a target fix is made on a target waypoint M, while if the fix is made to a normal B waypoint, then it's a navigation fix. Within each fix category, you can perform the fix either visually, by overflying the real waypoint position, or using the radar. We will practice making a visual fix when approaching waypoint B1. For now, we can do the preliminary steps of the visual fix procedure. The master mode knob should be at nav position. The computer data selector should be at ACT-POS, in UT mode. The waypoint to fix should be selected, on this case it is B1. Important, set the radar mode to A0, because this will be a visual fix, not a radar one. Continue flying towards B1, we will do the remaining of the procedure when we get closer to the waypoint. On the HUD, the timeline should have appeared. We are 40 seconds away from the B1 waypoint. Before you reach the real position of B1, prepare the visual fix by press and hold the radar trigger to its first detent, T1. While T1 is held, the destination indicator will display E1, meaning that a navigation fix is in progress. This will ensure that the waypoint does not switch automatically to the next waypoint when you approach its location. 7. Fly over the real location of waypoint B1, Corn Creek Town. When directly over the precise point, press the radar trigger to its second detent, TV. When you have pressed the second detent, the visual fix is performed and the position error is corrected. The drifted position that the computer had for waypoint B1 is shifted to the current position, which is the correct one. All other waypoints in the flight plan are shifted by the same offset, ensuring a consistent flight plan. The next waypoint in the flight plan, B2, will immediately be selected, since you have just overflown B1. Press hat trim right to have the autopilot make a turn towards B2. Good, you are now headed towards B2. You can now re-enable the radar by selecting mode A1. Later on the mission, when near waypoint B4, we will learn to perform a navigation radar fix. Be sure to bind the controls for moving the radar cursor, as the figure shows. Also, if possible, bind the controls for adjusting the radar display range. Finally, you may want to bind the axis for brightness and MKR gain, to fine-tune the radar display when attempting a radar navigation fix. Press spacebar to continue. The flight plan can specify a given time of day for reaching a target. For this training mission, we have to reach the M3 target point at precisely 17:55. You can check your exact time by placing the computer data selector on the TID position. Try it. The display shows a 5-digit time value, with the format hour, minutes, seconds. The first display position will be blank if you are early, or a minus sign if you are late. Return the selector to ACT-POS to have the navigation status on display. On the HUD, the flight path marker has a small vertical line, nicknamed the fin. When the fin barely touches the circle of the FPM, your speed is correct and you will reach the target on time. If the fin rises and separates from the circle, it means you are too fast and will reach the target early. Reduce your speed to compensate. If the fin sinks and tucks inside the circle, then you are too slow and will reach the target late. Increase your speed to correct. Do not stress too much with keeping on time, because the many pauses that I force on you whenever I need time for my explanations will make very difficult to be on time. Press spacebar to continue. The timeline on the HUD indicates how close we are from the B2 waypoint. Be prepared to press the trim head left when B2 is reached to have the autopilot turn towards waypoint M3. Now, turn left towards M3. As this is a target waypoint, enable Afterburner to increase the speed to Mach 0.9. The timeline indicates how close we are to M3. The target is located on a canyon, so be careful with the altitude. You are now over the M3 target point. You should be able to see it. It's the Hoover Dam. Now, turn left towards B4. Be sure to climb enough to clear the mountain range. Reduce the speed to Mach 0.55. The B4 waypoint is on the center of a peninsula. Set the radar display range to 15 kilometers, and adjust the MKR gain to have a better radar image. Press spacebar once you have a clear enough image of the peninsula. We will now practice a radar fix, using waypoint B4. The procedure is very similar to the visual fix we did at B1. Master mode should be nav. The computer data selector should be at ACT-POS, in UT mode. The waypoint to fix should be selected, on this case it's B4. Confirm the radar mode is A1. Adjust radar brightness and gain as needed. Adjust the radar display range to ensure that the waypoint circle is visible. Press spacebar to continue. Press and hold the radar trigger to its first detent, T1. A crosshair should appear on the radar screen. If the crosshair is not visible, move the radar stick a bit. Using its bindings, the crosshair should come onto sight. While T1 is held, the destination indicator will display E4, meaning that a navigation fix is in progress. Move the radar crosshair until it is on the center of the peninsula. Once the crosshair is just over the precise point, press the radar trigger to its second detent, TV. Good, the radar fix is performed and any position error is corrected. The drifted position that the computer had for waypoint B4 is shifted to the new position. All other waypoints in the flight plan are shifted by the same offset, ensuring a consistent flight plan. Adjust your heading, if needed, to fly towards the corrected waypoint B4. You have reached B4. Use the trim hat to have the autopilot turn left towards B5. Climb a bit to clear the mountains that are on the way. The timeline on the HUD indicates that we are nearing the B5 waypoint. Your airspeed should not be over Mach 0.55. You have reached waypoint B5. Use the trim hat to have the autopilot turn left, towards Nellis Air Force Base at waypoint L1. Enable the auto throttle, AFK, to have the aircraft reduce speed to 550 km per hour, as if we were initiating a landing approach. The AFK red light has turned on. Note that now you have no control over the throttle lever, the auto throttle has taken over. Open the air brakes to help the auto throttle to reduce the speed. We have reached 550 km per hour, close the air brakes. Disable the autopilot, to practice the alignment with the runways of Nellis Air Force Base. Fly over Nellis in order to finish this training mission. You have successfully reached the Nellis destination, however you skipped some of the waypoints, which means you failed to complete this training mission on pre-planned navigation. Repeat the mission some other time. Press spacebar to exit from the mission.